Now you'll remember in the last lesson we looked at parabolas and we looked a little bit at what happens when you change certain characteristics of a parabola. So if you put a number in front of the squared term, how it makes it thinner, for example. If you put a number on the end of the relation, it moves it up or it might move it down. This lesson is about parabolas in turning point form, and that's this one here down the very bottom, but we have to build up to that point. So you'll notice in that general form we have an A, we have a H, and we have a K. And so each of those values or variables are going to do a specific thing to the parabolic shape. So when you change the A, something will happen to the graph. When you change the H, something will happen to the graph. And when you change the K. We'll first look at what happens to them independently. So what is A? Well, A, you'll notice, is just the coefficient of the x squared term. So it's the very first value that you might see. And you might remember me showing you this in the last lesson. If I increase the value of A, at the moment it's 1, then you'll see it makes the graph thinner compared to the most basic one that you can have, that blue one, y equals x squared. At the moment A is 6 and a bit, nearly 7, and it gets thinner the higher that value goes. So A, you can always remember that A is what we call a dilation. So what we see here is as A gets bigger, the parabola dilates away from the x-axis. It gets further away from the x-axis. You can see as that number gets smaller that the graph gets wider, or it dilates towards the x-axis. At 0, we no longer have a line. It's just there across the x-axis is a straight line there. And the reason why that is because if A is a 0, well then our equation y equals ax squared will be y equals 0 times x squared. And anything times 0 is 0. So that's why we don't have a parabola at that point. But if we keep going down, you can see that not only does it dilate away from the x-axis, but it also flips. Now the mathematical word that we use is a reflection. So when the A is a negative value, the parabola reflects about the x-axis. So we have two things that A does. The first thing is that it dilates. The bigger the number, the more the dilation away from the x-axis. The smaller the number, the more the dilation towards the x-axis. And if it's negative, we have a reflection. So we have a dilation and a reflection that occurs when we change A. So if we move on to H, or H, we have the basic version, y equals bracket x take H squared. And if you look at this one, at the moment it's set to H being the 0, you can see it there. But if I turn it on, it looks exactly the same as the original blue graph, our reference graph, y equals x squared. That's because H is 0, so I haven't changed anything yet. Now watch what happens when I increase the value of H. So when the H value is positive, the graph moves in the positive direction. So I'll make that an easier number to track, make it 6. So when H equals 6, the equation or the relation will become y equals x take 6 squared. And you can see what that does. It moves the entire graph 6 places or 6 units to the right. So that turning point from the original blue graph was at 0, 0. It's now moved to 6, 0. So H actually moves the graph horizontal. You can remember that by H for horizontal. So if it's a positive number, the graph moves in a positive direction. And if it's a negative number, I'm sure you can guess, it moves in the negative direction. So H moves the graph positive or negative along the x-axis. This is what's called a horizontal translation. H for horizontal. So lastly, we're looking at K. What does the K do? Just to recap, the A dilated the graph, moved it closer or further away from the x-axis. It also reflected it. The H translated that parabola horizontally. There's really only one thing left that the graph could do, and that's another translation. You will see here that an increase in the K value shifts the graph vertically. This is a vertical translation. Now H for horizontal, K for vertical. But basically, if that number gets bigger, the translation moves vertically, well, it moves in the positive direction. And naturally, if the number decreases, in other words, when K is a negative value, the graph goes into the negative half of the axis.